We can accept many sentences as a mathematically acceptable sentences, which are called as statements. A mathematically statement is nothing but either it is a true statement or a false statement, and it cannot take both values at the time. The compound statement containing and is true. It is true if all its components are true. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am, lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So today we are taking up with the new chapter, that is mathematical logic. A logic is very necessary for any statements or any problems or any conditions to give a particular solution for a problem. So wherever in a life situation or in a mathematical problem, the logic is very important. So here we are going to learn in detail about the chapter mathematical logic and the terms related to it. In today's session, we are studying what do you mean by statements and negation of a statement, and what is the use of and, or, and some of the other words which are called as quantifiers when you are combining any statements in mathematics. Let's see it in details. So the very first one we have is a sentence. So what do you mean by sentence? A sentence is mathematically acceptable statement. Okay, it is either true or false, but not both. For example, we say the sun rises in the east. It's a true statement. And 3 divides 4. It's clearly false. It cannot be possible. 3 divides 4 is not possible. 6 is a multiple of 2 or 3. Yes, 6 is also multiple of 2 and it is also multiple of 3. So it is a true statement. A true statement or a false statement is nothing but a statement. So a mathematically statement is nothing but either it is a true statement or a false statement, and it cannot take both values at the time. That is, the same statement cannot be true and false same time. For example, here I have taken 2 plus 2 equals 4. So it was a true statement. Hence, the statement is true, so we can accept it as a mathematical statement. The sum of 2 positive numbers is positive. Again, this is a true statement. Hence, we can easily accept it as a mathematical statement. For example, we say, how beautiful she is. So, we cannot say whether it's a true or a false statement. So, where the statement you cannot apply the truth values, that is truth and false, that statement are not accepted as mathematical statement. So, to become a statement in mathematics, it should be a mathematically acceptable statement that either it should be true or it must be a false statement. So, next, check whether the following sentences are statements. Give reasons for your answer. So, the first one is 8 is less than 6. It is clearly a false statement because 8 cannot be less than 6, and hence it is a mathematically acceptable statement. So therefore we can call it as a statement. Next, the sun is a star. It is already universally accepted that sun is a star. It's a true sentence and we can call it as a statement. Next, how far is Chennai from here? We cannot apply any truth value or a false value here. Also, the word here cannot predict from where. So, therefore, we are unknown of this statement, whether it is a true statement or a false statement. So, this sentence cannot be a statement. So, like this, we can accept many sentences as a mathematically acceptable sentences, which are called as statements. Next, we come across negation of a statement. So, what do you mean by negation of a statement? Suppose I say the sun is a star. You have to negate it. Negate means exactly right, reverse of that. We have to take it not. That is, negation of any statement P is replaced by not P. So when I say sun is a star, we have to negate it by taking not. So therefore, how we will say the sun is not a star. So therefore, if you have any P as a mathematical statement, the negation of P is also one more statement. If P is true, then negation P might be false. If P is false, then negation P must be true. And it is always denoted by not P. Sometimes we use a symbol like this. Suppose I say 6 is a multiple of 2. It's a true statement. Write the negation of 6 is a multiple of 2. 6 is not multiple of 2. It's a false statement. So whether it's a true or false, it doesn't matter. Whatever the statement is given, we can negate it to make the truth values interchange. So if P is true, negation P may be false. If P is false, negation P will become true statement. Write the negation of the following statements. So here we have both the diagonals of a rectangle have the same length. We have to negate the statement. So they have given both the diagonals of the rectangle have same length. How to negate it? We will write both the diagonals of a rectangle do not have same length. So we are using do not here to negate the statement. The given statement is true statement, but we are making it false. That is what negation helps us to negate the statement. Next one is given root 7 is rational. How to negate it? Root 7 is, we can write not rational, or we can write root 7 is irrational. The given statement is false because root 7 is not a rational number. So therefore, root 7 is irrational becomes the true statement. So how to negate it? By taking not or by writing exactly opposite word to the given word. Next one, Australia is a continent. How to negate it? Australia is not a continent. Next one, the sum of 3 and 4 is 9. So what we will conclude? The sum of 3 and 4 is not 9. So 9 becomes not 9. Next, Chennai is the capital of Tamil Nadu. So Chennai is not the capital of Tamil Nadu. So next one, root 2 is not a complex number. They have given root 2 is not a complex number. We write root 2 is a complex number. So negating means it is not only just writing not. So whenever not is given, we will write without not also. So that is also the negation of a statement. Next, every natural number is an integer. So we write every natural number is not an integer. So these are the few examples that how we can negate a given statement. Next, we have compound statement. What do you mean by compound statement? In all the previous statement, you are having very simple statement, that is only one statement. So compound statement is a combination of more than one statement. For example, I can say, he is neither smart nor practical. If I take these two as a statement into two sub-statements, that is, he is not smart. This is one statement. One more statement we can write, he is not practical. So here we have two statements which is combined in the form of one single statement using the word neither nor. That is, he is neither smart nor practical. So the statements of this form, that is, a compound statement is a statement which is made up of two or more statements. So here it can also be divided into statements which are called as component statement. Okay, so if this is the compound statement, then you can divide the statements into two more statements. Here these two are called component statements of the compound statements. So here we have find the component statements of the following compound statement. So they have given the statement, you have to identify the component statements of the given compound statement. The sky is blue and the grass is green. So what are the two statements we have here? One statement is the sky is blue. Next, the grass is green. So these are the two separate statements, but they are combined from the word and to make a single statement. So therefore, this is called as compound statement, and these two statements, since it can be written separately, they are the components of the compound statement. Next, it is raining and it is cold. So the first statement is it is raining. The second statement is it is cold. Next one, 0 is a positive number or a negative number. So 0 is positive number, 0 is negative number. So these are the two statements combined with the word or here. So therefore 0 is a positive number and 0 is a negative number. Like this, we can make a compound statement with more than two or more statements. Next, the word and. So where is this and is used? And is used to make a compound statement. And whenever you have a word and, how to check whether the compound statement is true or false? So we have a conditions here. The compound statement containing and is true. It is true if all its components are true. For example, in the previous case, so look at the example here. We have the sky is blue and the grass is green. So the sky is blue, it's a true statement. The grass is green, it's a true statement. So therefore, the given statement is true. So therefore, the compound statement will become true when all the components are true statement. Otherwise, we call it as a false statement. So for example, if I say 6 is divisor of 36 and 40. So we can write the statement as 6 is a divisor of 36 as one statement. The second statement is 6 is a divisor of 40. The first statement is true because 6 is a divisor of 36. It is true. The second statement, 6 is a divisor of 40. It is false. So therefore, this statement is false. So what does this state now? The word and says the compound statement is true if all its components are true, and in any other cases, it is considered as a false statement. So let's take an example here. Write the component statements of the following compound statement. Check whether the compound statement is true or false. So here the question is given, 0 is less than every positive integer and every negative integer. First, let us write the compound statement. So we can write it as 0 is less than every positive integer. Next, we can write it as 0 is less than every negative integer. So these are the two component statements from the compound statement. So look at the first statement, 0 is less than every positive integer. Yes, the given statement is true. The second statement, 0 is less than every negative integer. So it is false. So if First statement is true, second statement is false. So when you have the word and, we take the compound statement as a false statement. A compound statement containing and is true if both the statements are true. In all the other cases, it is considered as false. So therefore, here one is true, the other is false. Therefore, the given statement is false. Next we have, as in the case of and, we have the word are. A compound statement containing are is true when any one of the component is true, and in all other cases, that is, it is false. If any one of the statement is true, suppose you have P and Q as two statements. If P is true, Q is true, then P or Q is also true. If P is true, Q is false, it is true. If P is false, Q is true, it is true. And if both are false only, it is false. So what does the word or says? The compound statement containing or is true when any one of the components are true. If both are false, then only it is false. So therefore, a compound statement with an or is false when both the components are false. So if any statement is given, to verify with or, we have to connect component statements, whether both are true or any one of them are true or two of them are also false. So using that condition, we can check whether the given compound statement is true or false. So let us take an example now. So consider another statement. We have taken 125 is a multiple of 7 or 8. So if P is the statement we have taken, it has to be divided into two simple statements. So the first statement I have taken it as Q. I'll take it as 125 is a multiple of 7. The second statement is 125 is a multiple of 8. Both statements are false. So if both the statements are false, clearly the compound statement is false. Since the word or is used, if one is also false, the other is also false, the compound statement clearly it is false. Hence, I have concluded both Q and R false. So therefore, the compound statement is also false. So in OR word, we have two more types, that is exclusive OR and inclusive OR. We have to understand where the OR is used, whether it is an exclusive OR or an inclusive OR. For an exclusive OR, I'll give you an statement. For example, tea or coffee is given along with the breakfast. So if you have a breakfast, either you will get a tea or you will get a coffee. You cannot get both at the same time. So therefore, that type of examples or statements are called as exclusive OR. So one item is excluded clearly. So the second statement I'll say, the student who has studied biology or chemistry can apply for MSc. So you have two options here. The student has to study MSc. Either he is from biology or from chemistry, he can take or he can study MSc. So here both are included. So therefore it is called as inclusive OR. So let's take an example, study it in detail. For each of the following statements, determine whether an inclusive OR or exclusive OR is used. Give reasons for your answer. So let's look at the first statement. To enter a country, you need a passport or a voter registration card. So clearly, what you can see here, either you need a passport or you need a voter registration card. Let's look at the second statement. Students can take French or Sanskrit as their third language. So either he can take French or he can take Sanskrit as a third language. So what do you observe from these statements? The first statement, clearly you can see, even though if you have the two or any one of them, you get an entry for a country. So clearly this is an inclusive OR. In the next case, either he'll take French, so he cannot study Sanskrit. Either he'll take Sanskrit, he cannot study French. So that means we are excluding one item here. So therefore, we take it as exclusive OR. So these are the two types of OR statements used in the mathematical statements. Next we have root 2 is a rational number or an irrational number. So either root 2 must be rational, then it is not an irrational, or root 2 must be irrational, so that it is not rational. So out of two chances, it is having only one chance. So therefore, clearly you can say this is an exclusive OR. Next, we come across a quantifiers. So quantifiers are the words like there exist for all. In many mathematical statement, you might use this word there exist or for. For example, consider this statement. There exists a rectangle whose all sides are equal. So it is there exists. The statement starts from there exist. And also, for every prime number, root p is an irrational number. So here the word used is for every. So the sentences which starts from or which includes these two statements are also called as mathematical statement, and these two words are called as the quantifiers. So they are the phrases. Which phrases means which combines two or more words. So therefore, there exist and for all is used for writing or stating a mathematical statement in mathematics, and they are also called as quantifiers. So here, identify the quantifier in the following statement and write the negation of the statement. So first we have to find the quantifier and then we will negate the statement. There exists a number which is equal to its square. So here what is the quantifier used? There exist. So how to negate it? So there do not exist a number which is equal to its square. So this is the negation of the statement. So here they are saying there exist. We have to write they do not exist any number which is equal to its square. Next question. For every real number x, x is less than x plus 1. First identify the quantifier. What is the quantifier word used is for every. So for every is the quantifier word used here, and they have given x is less than x plus 1. Now how to write a negation of this statement? So we will write for every real number x, x is not less than x plus 1. So this is how we will identify the quantifier and write the negation of the statement. So in today's session, we have learned few terms related to the logics, that is how to write a statement using some of the phrases as well as the words. So we will learn few more terms related to mathematical logic in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.